Wow, this research pile is impressive. Looks like we're going on a deep dive into the world of railways. You've really gone off the rails this time, haven't you?
It seems like your interest in railways is anything but narrow gauge. There's so much to explore here, from their historical impact to the cutting-edge technologies shaping their future.
It's just incredible to me how railways went from revolutionizing the world during the Industrial Revolution to facing stiff competition from cars, planes, even those massive cargo ships. What caused that change?
Well, you have to remember that railways were transformative in the 19th century. They connected distant communities, fueled economies. It was remarkable. Did you know that by 1850, steam engines in Great Britain were already hitting speeds of 125 kilometers an hour?
125 kilometers an hour. Back then, I always pictured those old steam engines just chugging along. That's faster than I drive on some highways today.
It's a testament to the ingenuity of those early engineers. But the 20th century brought about those new contenders for transport cars, planes, trucking. They each offered something new.
So railways went from a monopoly to a real battle for passengers and freight. How did they adapt?
They had to get creative. They started focusing on speed, cost effectiveness, better organization, and improving their services to attract customers.
So it became a race to offer the best value and efficiency. What are some areas where railways really shine in the transportation sector today?
When it comes to sheer volume, nothing beats rail. Imagine a freight train in Australia, loaded with ore, weighing over 32,000 tons. That's heavier than a whole fleet of jumbo jets.
Wow, that's a powerful image. So railways are the heavy lifters, but what about passenger travel? With planes dominating long distances, where do railways fit in?
Even with air travel, railways are still a popular choice, especially for travel between major cities. For example, the Shinkansen, Japan's high-speed rail network, carries a mind-boggling 520,000 passengers daily between Tokyo and Osaka. That's like moving an entire city's population every single day.
Wow, that's a lot of people choosing rail over air travel. What makes railways so appealing for those medium-distance journeys?
It's a few things. Travel time compared to flying is a big one, but also the frequency of service and the overall experience. Passengers care about convenience, cost, and comfort, and railways are working hard to meet those needs.
It sounds like they're holding their own, but I imagine they still face some pretty big challenges in today's world. Staying competitive and keeping up with new technologies has to be tough.
Absolutely. The need for speed, managing costs and pricing, and navigating the waters of privatization are huge hurdles. And we can't forget about environmental concerns, which are more important now than ever in the transportation industry.
Let's unpack those modern challenges, starting with the need for speed. You mentioned high-speed rail earlier. Tell me how railways are trying to satisfy the need to get from point A to point B faster.
High-speed rail has been revolutionary. We're talking trains reaching speeds of 250 to 320 kilometers, making them a genuine competitor to airplanes over certain distances.
That's impressive, but speed usually comes at a cost, right? How do railways balance the need for speed with keeping costs manageable for both passengers and freight customers?
It's a balancing act for sure. It's about finding that sweet spot between speed and affordability. And that's where the idea of generalized cost comes into play.
Generalized cost, what's that?
It means looking beyond just the ticket price and considering the value of someone's time. For instance, a busy executive might be willing to pay a premium for a high-speed train that saves them hours of travel time.
Time is money, as they say. Makes sense. But it's not just about speed and cost, right? There's also the way railways are structured and managed, and we've seen a lot of changes in that area, especially with privatization.
That's right. In many countries, we've seen those state-owned railway monopolies give way to privatization and more competition.
And what's the goal of that shift?
The hope is that it leads to better efficiency, improved customer service, and more innovation in the industry. A great example of this is the privatization of British Rail back in 1995.
That was a massive change. How did that impact things for British Rail and the people who rely on it?
It forced them to become much more customer-focused, using technology to enhance their services and attract riders. Things like online ticketing, real-time journey updates through SMS, and upgrading station facilities all came into play.
It sounds like they had to up their game to stay competitive.
Exactly.
We can't forget about the environmental impact of transportation. How are railways doing when it comes to sustainability?
It's a critical issue, and this is one area where railways have a real edge. Electric trains, especially when powered by renewable energy sources, are incredibly efficient compared to diesel locomotives, planes, and trucks.
Right, but electrifying a whole rail network is a massive, costly project.
It is, no doubt. But the long-term benefits often make it worth the investment. And it's not just about electrification. Railways are constantly looking for new and innovative ways to reduce their environmental impact, whether that's cutting CO2 emissions, minimizing noise pollution, or finding ways to reduce their overall energy consumption.
That's good to hear. Before we go any further, though, I'm curious about the technology behind these massive systems. What makes them so efficient, and what kind of engineering goes into moving such heavy loads?
Let's dive into the fascinating world of track and train technology, where steel meets innovation to create these incredible feats of engineering.
Okay, so we've talked about trains and the need for speed and efficiency, but what about those tracks themselves? They seem pretty straightforward, but I imagine there's more to them than meets the eye.
You're absolutely right. Railway tracks are like the unsung heroes of the whole system. They have to be incredibly strong and durable to withstand those massive loads and high speeds.
So what goes into building a railway track that can handle, say, a freight train carrying tons of coal or iron ore?
Well, it all starts with the rails themselves. For heavy-duty lines like those used for freight transport, you need rails made from high-strength steel alloys. And we're not just talking about making them thicker.
What else is involved?
The shape of the rail, what's called its profile, is also really important. It's designed to distribute those massive loads evenly and prevent the rail from deforming or, even worse, fracturing under pressure.
It's amazing to think about those rails holding up under so much weight. And then there's the issue of speed. High-speed lines must have different requirements, right?
Absolutely. For high-speed lines, the name of the game is minimizing vibrations and ensuring a smooth, stable ride. That's where continuous welded rail, or CWR, comes in. Have you heard of that?
Yeah, CWR came up in the research. It sounds like something out of a sci-fi movie.
It's pretty amazing. Basically, instead of having those short sections of rail bolted together, CWR uses these really long, continuous rails that are welded together. This creates a much smoother and quieter ride, especially at those high speeds.
So it's like a high-speed highway for trains without all the bumps and gaps.
Exactly. And that's just the rails themselves. There are all sorts of other fascinating things that go into building a railway track. Like the sleepers, those are the beams, usually made of wood or concrete, that sit underneath the rails and provide support. The spacing and material of those sleepers play a huge role in the track's ability to handle heavy loads and high speeds.
It's incredible how much engineering goes into something we usually just glance at from a train window. It's a whole system working together.
It really is. And we haven't even touched on some of the other cool features, like the ballast.
Ballast, like on a ship.
Kind of. It's that layer of crushed stone that you see surrounding the tracks. It might not look like much, but it serves some very important purposes.
Like what?
Well, for one, it helps to distribute the weight of the train evenly across the underlying ground. It also helps to drain water away from the tracks, preventing erosion and instability. And, believe it or not, it even plays a role in dampening noise and vibrations.
It's amazing how every little detail has a purpose. So we've talked about the rails, the sleepers, the ballast. It's like a whole symphony of engineering.
Exactly. It all has to work together seamlessly to create a safe and efficient railway system.
So we've covered the tracks, those steel ribbons that carry incredible weight and withstand incredible speeds. But let's talk about the real workhorses, the locomotives themselves. We've touched on the evolution from steam to diesel and electric, but what are some of the other innovations that have shaped these powerful machines?
Well, one of the most significant developments in locomotive technology has been the shift towards AC traction motors.
AC traction motors, I have to admit, I'm not familiar with those.
They're a game changer.
Yeah.
In older locomotives, DC motors were the standard, but AC motors offer several advantages.
Like what?
They're more efficient, for one thing, and they require less maintenance, which is a big deal when you're talking about machines that are constantly in motion.
That makes sense. Less downtime for repairs means more time on the tracks.
Exactly. Plus, AC motors offer better control and responsiveness, which is essential for high-speed rail and heavy-haul operations where precise control is crucial.
So it's about getting the most power and efficiency out of the locomotive. What about advancements in braking systems? Stopping those massive trains must be quite a challenge.
Braking technology is another area where there have been some incredible advancements. Early trains relied solely on friction brakes, which could be pretty unreliable and prone to wear and tear. But modern locomotives use a combination of friction brakes and dynamic braking.
Dynamic braking, how does that work?
It's really interesting. Basically, it uses the train's electric motors in reverse, turning them into generators to convert the train's kinetic energy into electricity, which is then dissipated as heat.
So instead of just relying on those brake shoes rubbing against the wheels, it's using the train's own momentum to help slow it down.
Exactly. And the beauty of dynamic braking is that it reduces wear and tear on those traditional friction brakes. Plus, it's more energy efficient because it's actually capturing some of that energy that would otherwise be lost as heat.
That's a win-win for both safety and sustainability. It's fascinating to see how these technological advancements work together.
It's a testament to the ingenuity and creativity of engineers who are constantly pushing the boundaries of what's possible.
This deep dive has been a real eye-opener. We've gone from the broad historical shifts in the world of railways to the intricate engineering details of the tracks and trains themselves.
It's a fascinating field, and it's only getting more interesting as new technologies emerge and the demand for sustainable transportation grows.
Speaking of the future, as we approach the end of the line for this episode, what's the one big takeaway you want our listeners to ponder? What's the question they should be asking themselves about the future of railways?
As we move further into the 21st century, the world faces some serious challenges. Climate change, dwindling resources, growing populations. Railways, with their inherent efficiency and potential for sustainability, could be a big part of the solution. So the question is, how can we create a future where rail transport isn't just a nostalgic reminder of the past, but a vital part of a more sustainable and interconnected world?
It's a question worth considering. It's been a fascinating journey, from those early steam engines to the cutting-edge technologies shaping the future of rail.
The railways have always been about connecting people and places, and it seems they still have a lot to offer the world.
Well said. That wraps up our deep dive into the world of railways. We hope you enjoyed the ride, and be sure to tune in next time for another fascinating exploration.